This is 10.3 Concurrent Lines. You have hopefully already looked at the websites to figure out how to construct the point of concurrency of the angle bisectors. What it means for something to be concurrent. It means that the point where two or more lines meet. So what I have drawn in here is I have drawn in one angle bisector and the other angle bisector. I chose not to draw on the third one. Now the special name for that is called the incenter. The reason it is called the incenter, or our cool piece here, is that we are able to inscribe a circle into by finding these angle bisectors. So once I find the angle bisectors, and this is actually a construction you're going to do in another day, we know, I'm just going to do a little sketch of it. If you want to inscribe that circle, you know that those are points of tangency. So from this point, which is the center of the circle, what you would do to inscribe the circle is you would do a perpendicular. So perpendicular down, you'd construct that, you'd physically construct that, gets you your circle. So then we would have an inscribed circle. And you're going to go through those steps in the next section. So then, our point of concurrency of the perpendicular bisectors. So the point of concurrency of the perpendicular bisectors is what we call the circumcenter. So I have perpendicular bisectors. They are meeting at a point. That means that this point, because any point on the perpendicular bisector is equidistant from all three ends of the segment. So from the two ends of the segment. So this point, this is equal to that. But then if the other perpendicular bisector for this side, this segment is equal to that segment. So now you have the radius of a circle. The cool piece here is that we are allowed to then circumscribe a circle. So there is the circle where this point, the point that we found, the point of intersections of our perpendicular bisectors, that's called the circumcenter. So the cool piece is I'm labeled to circumscribe a circle. Okay. Next one is medians. So our medians all intersect. Medians are from the vertex, from one vertex to the midpoint of the opposite side. So what you're doing there is you're getting the perpendicular bisectors. So you're constructing the perpendicular bisectors. So I've constructed those perpendicular bisectors. I'm going to make them go away. Just looking at those points, now we have the medians show up. So each one of those medians. So let's look at that, because there's a medians of a triangle theorem that this section talks about, and it's one of the few theorems we have in this chapter. Okay, so we have triangle ABC. Let's call those points X, Y, and Z, and M. Now, the medians of a triangle theorem says that the medians of a triangle intersect in a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So a point that's 2/3 the distance from each vertex. So that means that BM is 2/3 of the whole segment BZ. And MZ is 1/3 of BZ. Or another way to think about it, BM to MZ to BZ, well, that is 2 to 1 to 3. So they are in the ratio of 2 to 1 to 3. It is 2/3 the distance from each vertex. That means 2/3 of the whole segment is right there. I'm left with 1/3. because we're looking for one whole segment. Lastly, the point of concurrency of the altitude. Sometimes when you're drawing altitudes, you might have to extend the sides. So that's what these dashed lines are of our triangle. That's the extension of the sides. So you have those, and those meet at a point. And that point is called the orthocenter. I forgot to give you the name for the other one. The name on the other one is the centroid. So the point of intersection of all the medians is the centroid. So let me show you guys what that looks like. So M would be our centroid. Here, the concurrency of the altitudes is the orthocenter. So that's the orthocenter. And the cool piece about this is that the orthocenter of a triangle, the orthocenter the centroid and the orthocenter, centroid, and circumcenter are all collinear. So in a triangle, these 3 points are what we call collinear. And they are on a special collinear line called an Euler line. So a mathematical example has to do with the medians. So our medians. Each one of those are medians. AO, the entire segment, is 12. BX, I have to find BX. Well, okay. AX, this is 1/3 the length of the whole segment. So that means the whole segment is 9. BN, so 1/3 of BN is equal to 3, so therefore BN is equal to 9. 9 minus 3 is 6. Or you can also take and notice that xn twice xn is going to be bx. So twice 3 gets you 6. AX. Well, this is 2/3 of OA. So 2/3 of 12 is going to be 8. That means XM. This is twice the length of this whole of that segment. So therefore XM or MX is going to be 5. CM, the whole segment length, this is 5, that's 10, the whole segment length is 15. Segment addition postulate. You have no lesson questions for the day because you did all the constructions. Make sure the packet is complete for class.